Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode number 705 and 706. Design HashSet and design HashMap. These both are of same concept, and the prerequisite for this videos are you want to know about linked list and OOPS concept. And in linked list, you don't want to know about entire thing, but you want to know about entirely about singly linked list, and I will give the link in the description. If you also want to see about the W linked list and circular linked list, I will also give that in the description. You can also go there and check. Now, OOPS concept. In OOPS concept, you have to know about class and objects. That's it. These are more than enough for this problem. And a link for that also I have given in the description. Go and watch it and resume this video, or else you will be struggling in some parts. Right now, let's get started. Design a hash set without using inbuilt function libraries. Now, implement my hash set class. Inside that, what are the functions? What are the member functions? Here, add contains remove. Add is used to add a key, and contains is used to check whether it is there or not, and remove is used to remove a key from the hash set. Now, see this example. Initially, my hash set. So I have created a object for this. Then add of 1. So initially, that is my hash set. I have inserted successfully my 1. Now add 2. So inserted 2. Then contains 1. Whether it contains 1, yes. So that's why they have written what? True. Now contains 3. Whether it contains 3, no. So I will written what? False. Now add 2. Okay. Else there exists already 2. Already exists. So I don't want to touch anything. I don't want to do anything. Just leave it. Now contains 2. Whether it contains 2, yes, it contains 2. So that's why we will return what? True. Now remove 2. So I removed this 2. Yes. Now again contains 2. Whether it contains 2, no. So I want to return what? False. Can I understand this example? Right? So this is a simple set data structure. But we want to implement this without using this set data structure inbuilt libraries. Fine. Okay. So how to implement this? We have a basic idea. See here, hashing. So this is the basic idea. What is hashing? You may ask. Hashing is a value which is generated by doing some operations. Like, let us assume this is my array of size what? 5. 1, 2, 3, 4. So what are the indices? 0, 1, 2, 3, 4. So these are the indices. Now observe carefully. We have some set of elements like 30, 25, then 24, then 21, 22, then maybe 0. So these are the values. Now we want to store these values inside this array, but some of the values are exceeding the size of the array, right? The size of the array is 5. Some of them are exceeding the value of 5. So we are going to do a mod operation with the 5. By doing that, I can ensure that values will be lie between what? 0 to 5 minus 1, which is 4. Can I understand up to this? Okay. 30 mod 5, it is 0. So I will put 30 here. Now 24 mod 5, it is also 0. I put here. Now 24, I put here. Then 21, I will put here. 22, I will put here. Then anything else, 0. So I will put 0 here. Now see here, each and every index of the array should contains only one value. But how many values we have contained? We are containing what? More than one values in each and every indices. Maybe if I got a value as 28, then I will put here. Then again if I got 23, I again put here. Maybe that may be collisions. So this is called what? Collision. This collision occurs. To avoid this collision, we can go by two ways. What are those two ways? One is by using array, or we can also use linked list. Okay, this array, we don't prefer array basically. We prefer in linked list. But you may ask, array is faster to traverse than the linked list. Then why should we go for this linked list? You may ask. Okay, let me tell you why we are going to for the linked list in the end of this approach. Now come up with the linked list solution. I will tell you how we are going to avoid this collision. See here, to avoid this collision, if I construct an array here, I construct an array here, then put 0, then 30, then 25 at this index, like mattress. Like mattress, we can use the array. If not, I can construct a linked list node here, node here, node here, and connect this. Okay, so I hope you understand some concepts. Now see here, this is how it is implemented. Can you observe? Yes, there are some set of elements, and I want to make them to push into that, to this array. So I used this array, then I just push them everyone in this, in each and every cells, right? Now we are going to the operations. What are the operations? First we can see about, like, what is the operation that contains? Okay, contains. Fine. So what is mean contains? It checks whether it contains or not. If it contains the value, then it is true, else it is false. That's it. So this is the use of this contain function. Okay, let me give you 5. Okay. What is the hash value of this 5? 5 mod 5 is 0. So I go to this node, sorry, to this index, and check whether this 25 is equal to 5. No. This 0 is equal to 5. No. Whether this 5 is equal to 5. Yes, I found it. So I will return what? True. Fine. Now let us check for 100, or else 1 or 2. Already we visited that value, right? Now 1 or 2. What is the hash value? It is 2. So I will go here and check whether 32 is equal to 1 or 2. No. Whether there is any element exists? No. There is no element, no node exists after this 32. So end, and return what? False. Can you understand up to this? Right. So this is what the use of contains. Fine. Now we are going for the remove. How to remove a node? It is also quite simple. See here, if I say remove of maybe 0, 0. So if I want to remove this 0, I will go for the hash value 0. 0 mod 5, absolutely 0. So I will take this link and I will connect this link to this 5. That's it. Already I have told you deletion at position, deletion at end, deletion at start in detailed manner. So I don't want to repeat here also. Okay, I will take this next address and connect here. Okay, but how we are going to do this is quite tricky. I will take, if take for example 1 2 3, other 3 4. So these are the elements. If I want to delete this 2, what I am going to do is I'll take a pre, then a current, 2 pointers. I'll check whether this current is equal to 2 is a deletion value, right? Is equal to no. So I will make a shift of current and pre. Now again I'm going to check whether current and search value are same. Yes, it is same. So now I will take this link of my pre or next and connect here. So this is how we are going to delete it. Okay, fine. Here it is applicable. Now if I say here is my current and here is my pre, now my search value or my deletion value is 1. Then what should I do now? My pre is already none, right? Already none. So this is my index. Take for example, this is my index. Then I will store from this 2. Will make, like, I will store from this 2 in this cell. Okay, by that we can neglect this one. Can you understand till now? Yes. So this is the remove operation. Now at last, what is my operation? How to add an element in this hash set. So add has 2 types. What are they? If they already exist or not. Okay, I will call this contain function and check whether it already exists. If it is already exist, then don't do anything. Don't do anything. If not, then what should I do? If take for example, if I say add of maybe 21, right? 21. Now 21 hash value is 1. So I will go here. Then I will create a new node for this 21, right? First of all, we go for the contains function, then checking whether the 21 is present or not. it gives the result as false. There is no 21. So I'll create new 21 node here. Now, instead of traversing through this entire these nodes, I will take this 21's next to connect to this 26 and store this 21 as my this index. This index. Can you understand till now? Okay. I will also give one more example. If I want to store 20, whether 20 exists, no. Okay, what is the 20's hash value? It is 0. So I will create node 20 and connect its next to hash value 0, right? So 0 in this starting point and make this as our starting point. So I will replace this here. Now my linked list looks like what? 20, 25, 0, 5, 10. Can you understand up to this? So these are the operations we are going to do in a HashSet. Okay, let us see the code. It's simple. See here. First of all, what's the code for creating a single node for the single linked list? It is easy. Just create a class, and inside that we just use a constructor, and inside that we are going to initialize the data members with the values that are in the argument of the constructor. That's it. So what are the two attributes? That is two data member. They are, one is value and one is next. That's it. Now class my HashSet. Inside that I have given a constructor. Inside that self.size is equal to 1000. Self.container is equal to none into self.size. So I am just making array of size what? 1000 and initializing throughout that indices at what? None. In example, I told you like 5. Size is 5. But here in real time, I am using 1000. I cannot draw 1000 sets there, right? Now, next, defs add of key. So we are writing another function. Now, hash value is equal to key mod self.size. So I am getting the hash value by doing the mod operation. Now current is equal to self.container of hash value. If self.contains of key, then return. If it contains the key already, this link, this hash set, then don't want to do anything, just return. If not, then temp is equal to list node of key. So I am creating a new node. Now temp.next is equal to current. Now connecting this new nodes next to the current, that's starting point, and making this new node as a starting point. That's what the next line says. Self.container of hash value is equal to temp. That's it. Right? Now remove. Def remove of key. Now hash value is equal to key mod 1000 and current is equal to self.container of hash value. Tree is equal to none. Initially I take tree is equal to none, right? In that example itself I told you. Now while current, if current.val is equal to key, which means I'm go on traversing one by one. If there exists any value which is equal to key, then that should be my deletion node, right? So here is my pre, here is my deletion node. So I'll take this pre's address and connect with the next address to this current. If there didn't exist, already exist that key, then what will be my result? My current will end up with where? My current will end up at the last position. That means none. So in that time, we don't want to do anything. Okay. Now, if pre, then what should I do? Pre dot next is equal to current dot next. I want to connect it, right? I have to connect it. Now, else self dot container of hash value is equal to current dot next, which means deletion at the start. If the starting node itself the deletion node, then what should I do? I should replace the starting point as what? The next node. That's what I have done here. Then I will return it. Then pre is equal to current and current is equal to current dot next. That's it. I am updating constantly the pre, then updating the current to the next node. Now, def contains of self comma key. Hash value is equal to key mod 1000. Current is equal to self dot container of hash value. While current, if current dot val is equal to key, then return true. If not, I want to return false at last. I'm just taking one by one node, traversing. If I searched, yes, return true. If I not search, just return false. Okay. And at last, I want to say you that disadvantages of array, right? So disadvantages of array is we cannot insert or delete easily, but in linked list we can easily delete and insert it. So that's what the disadvantage of array and advantage of linked list. right? Even though linked list is slower while traversing, but while we are using insertion deletion operation, linked list is better than the array. Fine.